Very good evening and welcome back to my channel. My name is Himanshu Gupta and in today's video I will cover doubly circular linked list. In the last video I have already covered singly circular linked list. The only difference between the singly and doubly circular linked list is that in singly linked list we have only one pointer to store the address of the next node, while in doubly linked list we have two pointers, previous and next, to store the address of previous and next node. So let's first define the structure of the linked list. Struct node, and we will have three data fields, one for storing the data and one for storing the address of next node, one for storing the address of previous node. And that's it. This is our structure. So basically we have already covered in our DSA series the implementation of singly linked list, the implementation of doubly linked list. We have also implemented stack using linked list, queue using linked list, and in the previous video we have covered the circular linked list using singly linked list. So basically, when the last node of linked list points to the first node of the linked list, or when the last node of the linked list stores the address of the head node, the list is known as circular list. And today we are going to implement it using doubly linked list. I mean, this structure, our linked list will look something like this. This one. Suppose this is our head node, and today also we'll implement various operations on the linked list like insertion. We'll implement three functions for insertion: insertion at beginning, at last, and after a specific value or a particular value. I mean, we will search for a value in the circular linked list, and after that node we have to insert a new node. Likewise, we will be performing the deletion. So for deletion also we'll implement three functions: deletion from beginning, deletion at last, and deleting a specific node. Deleting a specific node, right? So we'll implement insertion, deletion, search, then display. Our display function will simply traverse the linked list. I mean, it will print all the elements of all the nodes of the linked list. So let's implement all the functions one by one. Let's first discuss the logic. Let me first define our global pointer head. Struct node head. Initially, we are initializing it with the null value. Now, let's start with the insertion at beginning. But before starting, let me discuss the logic with you. Suppose this is our say this is our linked list. Let me quickly draw it. It is a doubly list, so we have two pointers like this at each node. Okay, now suppose this is our head node and we want to insert a new node before the head node, right? This is our new node and we want to insert it before the head. So what should we do? See, if the list is empty, then our new node will become the first and the only node in the list, and therefore the head will be pointing to the new node, and the next of head will also be the new node, right? So this is one case. And if it is not so, if there are multiple nodes, if there are more than one nodes in the list, then what we will do, actually we need this node last. And how we'll create the last node? We can have the reference of last node like this: struct node last is equal to previous of head. As it is a doubly linked list, so we can access the previous node also. So the previous of head is our last node. So when we have last node and head node, we have to insert this new node between the last and head. So now it's become very easy. So what we have to do, we have to set some pointers like the next of node, I mean the next of new node should be head, the previous of head, the previous of head should be equal to n. Now the next of last, the next of last should be equal to, see, we have to join this, the next of last is equal to new node, and the previous of new node, the previous of new node should be equal to last. And after all these settings, our head node will become the new node. Our head will store the address of the new node. So this is our insertion at the beginning. Let me write it properly. Let me write this properly. Let me call this function as insert at beginning. Void insert at beginning, and we will insert this value. So first of all, we'll create a new node, struct node n is equal to struct node typecasting star malloc and size of struct node, right? So once we have created a new node, set its data field is equal to n. Now check if this is the case when the list is initially empty and the node that we are going to insert is the first node. See, when head is equal to null, that means the list is empty and the node that we are going to insert is the first node. So when this is our first node, we'll call it head. Our head node will point to this new node, and the next of head will be head itself because it is a circular list. So the next of head is equal to, sorry, the next of new node is equal to new, and also the previous of this new node will also be new node. The previous of new node is equal to n, and our head will store the address of this new node, right? Else, what else? I have already discussed the logic with you. Else, will create a will create a node last, which will store the address of the last node. Last, since it is we are dealing with the doubly linked list, so we have access to next and previous node, and we have a head pointer, so we can access the last node using the head previous of head previous. So we have last node. I mean, suppose this is our last node, and this is our head node, and we have to insert a new node in between, and we are calling it new node n. So we have to, set these pointers and these pointers. That's it. And after that, head will store the address of this new node. So the next of new node is equal to head. The previous of new node is equal to last, and last next, you can see from the diagram, the last of the next of last is new node, and the previous of head node, the previous of this head node is new node, the previous of this head node is new node, and after setting all the pointers, our head will become the new node. Our new head is the new node, right? So uh, that's it. This is our insertion at the beginning. This is our insertion at the beginning. Now, insertion at last is almost same. What is the difference actually? In the insertion at last, the we have to set the same pointers. The only difference is that will not change the position of the head node. I mean, head will remain at its original position, right? Will not call the new node as the head node. Rather, it becomes the last node. So let me write it properly. Now I'll call this function as void insert at end, and we will pass a integer type value in the function. So first of all, as usual, we have to create a new node, then only we will be able to insert the node in the linked list. Struct node, let me call the new node as n, and the typecasting is struct node malloc and size of struct node. So we have created a new node. Now let's assign its data value as n. Now again we have to check the case when the linked list is empty, and the node that we are going to insert is the first node. If head is equal to null, that means list is empty, initially empty. Our circular list is initially empty, and if it is empty, that means the node that we have inserted is the only node in the list. So its next will point to itself and its previous will also point to itself, and it becomes our head node. So the next of new is equal to new itself, and previous of new is also new, and our head will point to this, right? Otherwise, else, remember we have to insert a new node in the last. So suppose this is our head node and there are many nodes here, and this is our last node, and they are connected like this, and I want to insert a new node after the last node, right? So first of all, let me create the create a pointer to the last node, and last is equal to, since we are dealing with the doubly linked list, we can easily find the address of the last node using previous of head, right? So we can now access the, we have now the reference of the last node. Let me call this last and head, and we have to insert a new node in between last and head. So we have to simply set these pointers, right? So now what I have to do, you can easily see from the diagram, the next of new node is equal to head, and the previous of new node is equal to last, and the next of last is equal to new node, and the previous of head is also new node, and that's it. In this case, we don't need to change the head pointer, right? So this is our insertion at end. It is very simple and intuitive. Now let's write the function for the insertion after a specific value. So I have to write void insert after int value, and int, this is the value of the node that we have to insert in the linked list. So let me first create, as usual, let me first create the or before creating a new node, let's first check the age condition. I mean, we have to see, we have to insert the new node after a specific value, right? So if we cannot find this specific value in the node, we cannot insert our new node after that value, right? So the one case is, if the list is empty, then we cannot insert this value after the list. Okay, so if our list is empty, if head is equal to null, that means list is empty and we cannot find this value v in the list, and therefore we cannot insert the value, insert a new node and after the v. So we can simply print a message that list is empty and cannot insert after percentage d, v. And we can then return from here. Now let's create a temporary node, struct node temp, which points to head. Okay, so now we will search for the desired value, and if the desired value is found, we'll create a new node with value n, and after that we'll insert it at at the desired location. So for this we'll use a do while loop. Now if the data of temp is equal to value, this means we have found the node. So let's create a new node, struct node n is equal to struct node malloc size of struct node. Okay, now let's set this data field as n. Okay, now please see, we have to, if suppose this is the circular linked list, something like this. We have some nodes in between also, and suppose this is the specific node after which we have to insert a new node. I mean, this is the node V which we were looking for, and after this node we have to insert this node n. I'm calling it capital N with value n, right? So we have to insert this like this, and this node is our temporary node. Temp, I mean our temporary pointer is storing the address of this node. So now how can we insert the new node after this? See, the next of new node, the next of new node is equal to the next of temp, the next of temp, right? I mean, we have set this pointer. We have to set the 4 pointers, right? And this is the one that we have set. Now the previous of new is equal to temp. This is our second pointer, right? And we also know that temp next is equal to new node. So temp next is equal to new node. Now what is left? This one, the next of temp, and its previous pointer should be store the address of this new node. So we can write temp next and its previous is equal to n, and that's it. We have now successfully inserted the node, and we can return from here. This is our if block, and after the if block Let's increase. Temp is equal to next of temp, and this is our while loop, do while loop, and the condition is will traverse the loop until temp is not equal to head, right? So after insertion we can also print a message, sorry, when see, if we could not find the value, I mean if the data node that we are looking for is there in the linked list, we'll find it, and we will insert a new node after the value, and will return after inserting the value, right? If even after completion of the loop we cannot find the our desired value, that means the value does not exist in the list, and therefore we can print a error message, or you can say warning message, that node with value %d not found, right? So this is our insertion. Now we have discussed all the cases of insertion. I mean, insert at the beginning, insertion at the end, and insertion after a specific value. So far with so many examples of a linked list, you have understood that if we are talking with about the doubly linked list, we have to set certain pointers. I mean, if I have to insert a node, between two nodes, and each node has two pointers, next and previous, next and previous. This is previous, and this is the next of this, and previous of this. So remember, when we are dealing with the doubly linked list, you need to take care of these pointers. Four pointers you have to set. And if we are dealing with the singly linked list like this, you need to set this two pointers, right? Rest everything is very intuitive. So now let's discuss the case of deletion. So we again have three situations: deletion at front, deletion at last, and deletion and deleting a specific node, you know a specific node with value v, right? So let's implement all these functions one by one. Let me first write the function for insertion, for deletion at the beginning, and let me call it void delete first. So you must have seen that in that whenever we delete some element from any data structure, let it be stack, let it be queue, let it be linked list, singly linked list, doubly linked list, or whatever, whenever we delete something from any data structure, we first check the underflow condition. So here also we'll check if head is equal to null. I mean, if the list or an data structure is already empty, then we cannot delete anything from it. So underflow condition, checking the underflow condition is very important. Printf list is empty, and return. Okay, now suppose what we are trying to do, we want to delete the head node, right? See, if it is the head node, it is we want to delete this. It is a doubly linked list, so we have both previous and next pointers, right? I want to delete this node from the list, from the cycle, and if I delete this, will connect its previous node with the next node like this. This should be done. So how is it possible? We'll first, since we are dealing with the doubly linked list, we can easily find the address of the last node of the list. So let's first create a temporary node, struct node, temp is equal to head, and uh, let's first discuss the case when there is only one node in the list. If there is only one node in the list, how will we find it? If next of head is the head itself, that means there is only one node in the list, and in that case we'll simply free it and head will become null. Free head, and now list is empty and our head is now null. Okay, otherwise what we have to do, as I have already discussed, we need to delete this one, right? So I need to access this its previous node, and its previous node is last. So let's first create a pointer, struct node, last, and last is previous of head, right? So now when we uh, have the last pointer, see, suppose this is last, this is our head, and it is this is its next node, right? They are connected like this. I need to delete this, and I have already created a temporary node that is pointing towards this uh, head. So let me write head is equal to next of head, right? Now I am calling the next node of head as head node. So now I simply need to connect this like this. Just make these two connections. I mean, next of last is equal to head, and the previous of head is equal to last, and our this is our old head whose address is stored in the temporary node. So we can safely, remove this. We can safely delete the space occupied by this using our free function. That's it. So this is our simple and intuitive function of deletion at the front node. Okay, now let's write the function for deletion at the last. So void delete last. Okay. So see, deleting the last node. Suppose this is our head node and we want to delete this one, right? This is what? This is previous of head. Let me call this last. So somehow I need access of this. I need, access of this node. Let me call this second last, right? So if I have address of second last node, then we can safely delete the last node because we can connect. I can connect second last with the head like this, right? So this is the logic that we are going to implement in this delete last, implementation. So first of all, we'll check the underflow condition. If head is equal to null, that means list is empty. We'll print simply that list is empty and will return from here printf list is empty and return. Now struct node, let's create a pointer last, and last is previous of head, right? So if this is the case when the list is having only the one node, I mean when the next of head is pointing towards itself, when head of next is equal to head, that means list contains only one node, so we'll simply delete it, the head, and simply in this case our head becomes null, and that's it. Else, okay. Okay, so as discussed, I need access of this, second last node. So let me define, we already have a pointer last, so let's create another pointer, struct node, and call it second last. So second last is equal to previous of last, simply, right? And now when we have a last node, when we have second last node and head node, then my task is only to connect them, right? So it is very simple now. Simply the next of second last will become head and previous of head becomes second last. That's it. I only need to write these two lines, and then we can safely remove the last node using free function. So second last next is equal to head and previous of head is equal to second last, right? And now we can safely delete the last node. So this is our deletion at the last function. Now let's come to our last deletion function, that means deletion at deleting a specific node which contains the value v. So I'm calling this function as void delete node, and we'll delete the node with value n, right? So here also, in this function also, we'll check the underflow condition. If head is equal to null, what we will do, printf list is empty, and we can simply return from here. Otherwise, let's start searching from the first node. We first need to search for this node n. So I need a temporary, you know, pointer node temp will start from head. See what we are going to do. Suppose this is the list. It is a doubly list, doubly linked list, doubly circular. So it has two pointers, previous and last, like this, right? So each node contains some value like 10, 20, 30, 40, 50, 60, like this. And suppose I want to delete the a node having n is equal to 30. I mean this value I want to delete. So first of all, I need to locate that node, right? So this requires linear search. Will linearly search, you know, will compare the value with each node, and whenever we find the match, we'll delete it. So if I want to delete this, I need to access its previous element, right? So its previous element I can easily access. I mean, this is our temporary node. I can access its previous node. So this is suppose previous of temp, right? I can create a new pointer which will store its address, and let me call it previous. So if I have previous node and temp, then I only need to connect this. I need to make these connections, right? So first search. Let's search for this value n in the list. If temp data is equal to n, then if temp is equal to head, that means it is the first node, right? That means if temp is equal to head, this means it is our first node. So we can directly call our function delete first, and we will return from here, right? Otherwise, I'll create a node previous which will store the previous of temp, and I can also, you know, have a pointer next, which stores the address of next. So I only need to now the our task is to connect this, previous with the next. So previous next is the next, and next previous is the previous. That's it. These two lines I need to write, and after that we can safely remove the temporary node. So previous next is equal to next. See, I have created two pointers. I'm calling this as previous node and calling this as next node, and this is our temporary node, right? This node we have to delete. So previous next is equal to next, that's it, and previous of next is equal to previous. Next previous is equal to previous. So we have made the connections. Now we can safely delete the temporary node, right? And we can simply return from here. So this is our if block, and after if we can navigate the loop. We can like this, temp is equal to next of temp, and this is our do while loop. While temp is not equal to head, right? If we could not find the value in the loop, that means the node is the node that we are looking for does not exist in the list. So we can simply print a message that node with value %d not found. That's it. This is our delete node function. So we have covered all variations of insertion and deletion in this doubly circular list. Now let's implement another function, count node. In count nodes. So this is very simple. In this function we simply need to traverse the whole list. I will initialize I will take a variable count and will initialize it with the 0. So let's first take the base case. If the head is equal to null, that means our list is empty, and in that case we'll simply return 0. That means our node count is 0. Otherwise, initialize a variable count with 0. Take a temporary variable. For traversing the list, we always need a temporary variable. Temp. Initialize it with the head. Now let's use our loop and count plus plus, and temp is equal to next of temp. So This is our do while loop. It will run until temp is not equal to head. And here we will return count. See, here we have used the do while loop and not used the while loop. I have used do while loop because of one reason. And what is the reason? We have started with the temp is equal to head, right? We have started with temp is equal to head, and the condition of our loop is while temp is not equal to head, right? So if I use while loop in place of do while loop, this condition will never be true, and the will not be able to enter inside the loop. So that's why we cannot use while loop at this place, right? I hope you understood my point. Now the next function is search function. So it is more or less same. In search, we have to search for this value v. So again, we'll include the base case if head is equal to null. Simply return 0. This search will basically search return whether this node exists in the linked list or not. So it will return only 0 and 1. If it is returning 0, that means node does not exist, and 1 means node exists. Now take a temporary struct node. Let's declare a temporary pointer, initialize it with the head, and use a do while loop. Remember, we cannot use while loop here because our condition is our until no temp is not equal to head. If temp data is equal to value, this is basically linear search in the list, right? So if we found a match, we will return 1, and temp is equal to next of temp. So this is our do while loop, and temp is not equal to head. This is the condition, right? So if even in the loop could not found the data, that means the node that we are looking for does not exist in the linked list, and then we will return 0. 0 means node not found. So this is our search function, and our last function is the display function. I mean, we have to, let me write the display function here itself, void display. So it is almost same. We will include same underflow condition. If head is equal to null, that means we can print our list is empty. List is empty, and return. Otherwise, I need a temporary node, struct node, temp is equal to head. We'll use the same loop, do while temp is not equal to null head, and that's it. This is our Here in the loop, we'll simply print the data percentage t temp data and temp is equal to temp of data. So this function we have used many times in our previous examples also. So this is all about the doubly circular linked list. I hope you have enjoyed the video, and now your concepts, now your understanding of linked list and circular linked list has improved. So let me just demonstrate this code using our online compiler. Okay, so in order to save the time, I've already written the code here. This is the structure of our doubly circular linked list, right? Since it is a doubly list, so we have two pointers, next and previous, to store the address of next and previous node. Then we declared a global pointer head. Then this is our insert at beginning function. It is exactly same that we have discussed in our video. Then insert at end, insert after. All the functions are exactly same that I just discussed in the video. Delete first, delete last, right, and delete node. Then our count node function, search and display, right. Now this is our driver code, main method. So what we are doing here, we first inserted certain values at the end of the circular linked list, 10, 20, 30, 40. Then we displayed the whole list. Then we inserted an element in the beginning, and again display the list. Then we use the our third insertion method, insert after. After that, we are searching for 25 nodes, 25 whether it exists in the list or not. Then delete first function, we have demonstrated delete first function followed by delete last, and then delete node. And after that, after each function, we are displaying the list. So let me just run this code, and you can trace the output with the input. So first, you know uh, you can see we have inserted four nodes, 10, 20, 30 and 40 at the end. So first we have inserted 10, after 10 we inserted 20, after 20 we inserted 30, and followed by 40. And since it is the circular linked list, circular doubly linked list, the head will follow up after 40. Then after inserting 5 at the beginning, this 5 will come at the beginning. After inserting 25 after 20, so where is 20? 20 is here. So you can see we have inserted 25 after 20. Now the total number of nodes, we have called the count node method. So there are 1, 2, 3, 4, 5, 6 nodes, and our program is also returning 6. And then we search for node 25, since it exists in the circular linked list. Uh, we have the output node with value 25 found. Then we delete the first node. The first node was 5, it is deleted. Then we deleted the last node. The last node was 40, it is also deleted. And then we deleted the node with value 25. So that was the third implementation of our deletion method. So after deleting all the nodes, we are now left with the three nodes, 10, 20 and 30. So thank you very much. I hope you have enjoyed the video. So if you are new to my channel, please do like this video and subscribe my channel. I made videos on various topics of computer science. Like this is the playlist. You can search for Shift Tech tutorials, and this is the playlist. I Right now I'm mainly creating videos on C++ and data structures. So thank you. I hope you have enjoyed the video. This is the complete list. Do share it. Uh, do share this channel with your friends also. Thank you. We'll see you in the next video.